Welcome back, everybody. Hopefully, everybody is well. One last hypothesis test for an unknown population proportion will be an upper tail test. This is how the problem reads. In a study of 11,000 car crashes, it was found that 5,720 of them occurred within 5 miles of home, based on data from Progressive Insurance. Use a 1% significant level to test the claim that more than 50% of car crashes occur within 5 miles of home. Are the results questionable because they are based on a survey sponsored by the insurance company? Again, we're going to show the critical value method, which is to show all 5 steps. Step number 1, of course, is to always clearly show the hypotheses that are being tested. And the claim is that more than 50% of all car crashes occur within 5 miles of home. More than suggests greater than, so that will be our alternative hypothesis statement, saying that the population proportion of all car crashes that occur within 5 miles of home is greater than 50% or greater than 0.50. And therefore, the null hypothesis H sub 0 has to say that the population proportion is equal to 0.50. So you can see why it's an upper tail test, because the alternative hypothesis has a greater than symbol. Step number 2 is establishing the level of significance, the probability of committing a type 1 error should we have evidence to reject the null hypothesis. And we're going to test at 1%, so we set alpha equal to 1%. Step number 3 now is computing the test statistic value. And the test statistic formula, again, is a z-variate distributed according to the standard normal distribution, which is to say it's the sample proportion minus the purported population proportion under the null statement divided by the square root of p sub 0 times 1 minus p sub 0 divided by the sample size. Now, for this example, our sample proportion p hat is going to be, which is always in general, x divided by n. X is the number of car crashes that actually occur within 5 miles of home, which is 5,720, divided by all the car crashes that occur within 5 miles of home that were randomly surveyed, which is to say our sample size, 11,000. So when you do this division, your sample proportion should be 0.52. Now we bring p hat down into our test statistic formula and incorporate it in place of p hat. So 0.52 takes the place of p hat. And then we're going to subtract off the purported population proportion under the null, which is to say we subtract off 0.5. All of this needs to be enclosed inside parentheses to stay off a logical error on your calculator. And this is divided by the square root of p sub 0, which is 0.50, or 0.5, times 1 minus p sub 0, which is 1 minus 0.5, divided by your sample size, which is to say divided by 11,000. All right, ladies and gentlemen, when you dial this up on your calculator, you should get your test statistic value, which is about 4.195. Now keep in mind, a test statistic is not a probability. It's not a proportion. It's a value that lies on the horizontal axis of the z distribution. Step number 4 now is establishing the rejection acceptance region. And please do always draw a picture of the distribution and the rejection region or regions. This is an upper tail test, and so the rejection region will find itself in the upper tail of the standard normal probability distribution, whose size will be equal to the level of significance we set back in step 2, which is to say 0.01. So this critical z value we must find. To find it, I'm going to use my inverse norm function. Now I'm going to type in 0.01. Now I know that's not the area to the left of this critical z value, but by symmetry, If we thought of our z-value as being a negative z-value down here, we could say that the area was 0.01 to the left of it. We'll just drop the negative sign on our value so that we'll have the positive z-value as our critical value, as we should have. Of course, the mean and standard deviation of the standard normal distribution is 0 and 1 respectively. When you crank this value out, you'll get a critical z-value of about 2.33. Now we look at our test statistic value back in step number 3, which is 4.195, and you can see that 4.195 is greater than 2.33, so it falls safely in the rejection region. And so therefore, ladies and gentlemen, sample evidence is overwhelmingly strong enough to suggest that we're going to reject the null hypothesis and we're going to support the claim in saying that the proportion of all accidents that occur within 5 miles of home is indeed greater than the majority, or greater than 50%. So therefore, step number 5, our conclusion, you can state simply this. You can state it as saying something like this: sample evidence is strong enough to suggest that more than 50% of car crashes occur within 5 miles of home. And ladies and gentlemen, we only stand a 1% chance of rejecting a null hypothesis that indeed could maybe in fact be true. And so we stand a 1% chance of committing a type 1 error. And that's not really much a risk. So I would probably definitely in this case reject the null hypothesis and definitely go with the claim that was stated. 1% chance of rejecting a null that may in fact be true is a very low level of risk. So this is a rather conclusive test, to say the least. So this concludes an example of a one-tailed test, or in specific, an upper tail test for an unknown population proportion. Okay. Now, what I'm going to do is I'm going to run through these 3 problems again, but I will show you the p-value method. That is the method that utilizes a calculator to conduct these hypothesis tests. Those will be coming up on future videos.